Okay, so now we have this question that a machine runs at 5000 RPM, its forcing frequency is very near to its natural frequency, and if the nearest frequency of the machine is to be at least 20% from the force frequency, we design a suitable absorber for the system, assume the mass of the machine as 30 kg, the value of M2 will be. So basically, yeah. So basically, uh, we know that okay, we have been given the speed that is this 5000 RPM, and it said that the forcing frequency is very near to its natural frequency. Okay, so this has been given. Basically, we can replace omega with omega n. And now it's asking that the nearest frequency of the machine is to be at least 20% from the force frequency. Okay. So 20% by 20%, it means that it can either be 20% greater than it or 20% less than it. So basically it is telling us that omega upon omega 1 can take the value of either 0.8, okay, that is 0.2 less, and 1, sorry, and 1.2, that is 20% more. Okay, let me. So basically this has been given to us, okay, and also the mass m1 is given, okay, m1 is given, right, 30 kg, and m2 is something we have to find, okay, and now we know that mu is equal to m2 upon m1, okay, we have defined this already. uh, Wait a minute, sorry. Yeah. So, yeah. Now we also know that we derived from the like when we calculated. Okay, I cannot do the whole derivation again. We know that when we calculate the responses, okay, x1 and x2 for the system, okay, and we express them in the form of x1 delta st, and we give names to a number of terms, like we define mu there, we define g and everything. So there we know that the equation okay can reduce for finding the mu value as omega omega upon omega 1, okay, omega upon omega 1 square, okay, is equal to 1 plus mu by 2 and plus minus mu plus mu by mu square upon 4, okay, this is the form you know already, right? And also here this omega upon omega 1 it is given, so mu you can definitely find. So another form for this equation is, if I say replace omega upon omega 1 by r, okay, so we know that it comes down to mu is equal to r to the power 4 plus 1 upon r square, right, minus 2. So something like this. And now when you put the value of r equal to 0.8, okay, in this equation, okay, so mu is equal to 0.8 to the power 4 plus 1 upon 0.8 to the power 4 minus 2. Okay, I have solved this already. So for this, the value of mu comes out to be 0.2. Okay, now if I put the value of r equal to 1.2, that is the value of omega upon omega 1 equal to 1 by 2. That is when the second case is there, it is 20% more than the it is basically 20% more than the force frequency. So from here mu is coming out to be, okay, 1.2 to the power 4 upon 1 point plus 1 upon 1.2 to the power 4 minus 2, and it comes out to be 0.13. Okay, so these are the two values of mu which we are getting. Now for the designing purpose, obviously we will take the larger value of mu. Okay, so we consider mu is equal to 0.2, right? Now it implies that m1 upon m2, sorry, m1 upon m2, okay, uh, no, basically m2 upon m1, okay, is equal to 0.2, because I have defined m1 as the mass of the main system. So now it is given m1 is 30 kg, so m2 is equal to 30 into 0.2, right? So it should be 6, okay, yeah, 3 2s are 6, so it will be 6 kg. So I think this should be clear. Okay. Now we can you can take notes from this. Okay. And we can now move to the next question. So you can see that the next question is similar. Okay, now you have been asked the value of K2. Okay, the machine is again running at 5000 RPM. Its forcing frequency is very near to its natural frequency, and the nearest natural frequency is this. So basically it is the same question. You can consider it as the second part of the question. Now you have to design a suitable K. Okay, you have to take the value of K2. Now you know that it was given in the question. Okay, this line is important. Forcing frequency is very near to natural frequency. So omega is equal to omega n. You can take this value here. Now you know that omega n will be equal to what? Under root of k2 by m2. So it implies that omega n square into m2. Okay, if I take square on both sides, it will be omega n square into m2 is equal to k2. So from here you can simply write k2 is equal to omega n square into m2. So omega n is given as 5000 rpm, okay, and m2 is 6 kg. So first we know that omega n is equal to 5000 rpm, which is equal to 5000 into 2 pi by 60. So we convert it to radians per second. So basically I a calculator, so let me do it. My phone. Sorry, it's 60, 2 pi upon 60. Okay, so it is coming out to be 523.598 radians per second. So I can put this value here, okay. So plugging in the first equation, it implies 523.598 square into 6. Okay, and this value, maybe I have calculated it somewhere. Yeah, so it comes out to be 1643.24 kilonewton per meter. Okay, so this is the value of K2.